Welcome everyone. Let us look at the electrolysis of some selected electrolytes. Why do we want to look at this? This session will actually make you understand the previous sessions better. When we talked about preferential discharge of some ions, we mentioned about different factors, and in this session we are going to look at why do we have certain ions being discharged in relation to the others. What is unique is that we are going to move from one electrolyte to the other, and we'll see what ions are in that electrolyte, and then we'll see which ions are going to be discharged. Okay, so we'll also look at the products that come out of this electrolysis. Why do we have certain products and we don't have others in certain situations? Okay, so that's what we're going to look at. Typically, before I start, when we talk about electrolysis, we're talking about a solution that is decomposed into its constituent ions when electricity has been passed through it. Okay, so therefore, for all the examples that we're going to talk about, there is a source of power or a source of electric current going through the electrolyte, through the electrodes, the cathode and the anode. Okay, so that would be the basis of our discussion. So the key point here is that for you to know the products of a particular electrolytic reaction, you need to know which ions are going to be discharged. Okay, meaning that you have, if for example you have sodium ions and hydrogen ions, one of these will be discharged. Okay, so which one will be discharged? Because if we discharge sodium, it means that we'll have electron there and get what you call sodium, which is actually solid here. This is aqueous, right? That's what will happen. So it means here you have lost the charge. So this is the product. And now when you have hydrogen, you'll have electron again, and then you'll have hydrogen gas being produced here. Okay? Just if you balance it like that. Okay? This is still aqueous, right? So that means that depending on what is discharged here, you will have different products. You can have sodium, or you can have hydrogen. And one major guiding factor is what we call the electrochemical series, where we have a list of elements and the ease with which they can be discharged. And we say that the one which is lower is usually discharged in preference with the one which is above. Okay, we look at that. Okay, so that therefore means that for us to be able to know what is discharged, apart from knowing the electrochemical series, which is under this point here, but also knowing the nature of the electrolyte that we are having, because the electrolyte will tell us the nature of ions that we find in that electrolyte. Okay, and then after knowing the nature of the ions, then we can say this one will be discharged because the electrode is this, or because the concentration of the ion is this. So these are basically preliminary information that you really need to know in our discussion that is going to follow. So we are going to look at the electrolysis of a number of these electrolytes, and we are starting with molten sodium chloride. Molten sodium chloride is basically the opposite of diluted sodium chloride. Here we are not talking about any water being present here. We are only having the sodium chloride, which is in the molten state. Okay, so what happens if you connect a source of power to this solution of molten, this molten sodium chloride? What will you see? The electrodes that you will use, graphite, you have graphite electrode, and then you also have iron or steel. What we are saying here is that the anode has to be graphite. The anode is graphite, okay, and then the cathode can be steel or iron, okay, and then the electrolyte is the molten sodium chloride. Okay, so what ions do we find there? Definitely we're talking about the sodium ions and the chloride ions. Okay, so remember that you will have the positively charged ions moving to the cathode. So at the cathode you'll find the sodium ions because they're positively charged. And what will happen at that point is that they will get discharged. They will get discharged. And then at the anode, you'll have the negatively charged ions, which are in this case the chloride ions. For them, they will lose the negative charge and then become chlorine gas. Okay? They lose the electrons to become chlorine gas. Okay? So the overall reaction is that you have sodium, which is molten soft sodium, and then chlorine, which is a gas. Okay, so remember this one is at the cathode, and then the chlorine is at the anode. That's what you see. So the chlorine is a greenish yellow toxic gas that can be used for different uses in the industry at the industrial level. And then you can also have the slippery metal, which is in this case sodium, which is highly reactive. Okay. Now let's move to the second electrolyte. In this case, we are talking about dilute sodium chloride solution. So this is to tell you that there is water in there. Okay, so we're going to have ions that are coming from sodium chloride, but also ions that are coming from water. Okay, but the products of this electrolysis would also depend on the nature of electrodes being used. If you use mercury as a cathode, you'll get what you call sodium amalgam at the cathode. If you use platinum cathode, then you will get hydrogen gas as the product there. So this is the other stress point that we want to stress, is that the products of electrolysis can depend on the nature of the electrolyte. That means that the ions that are present in the electrolyte and the position of these ions in the electrochemical series, but also on the nature of the electrode that we have. And for example, in the electrolysis of dilute sodium chloride, if you use mercury as the cathode, then you're going to have sodium amalgam there. But if you use platinum as the cathode, then you're going to have hydrogen gas as the product at that point. So we are now referring to platinum as the cathode. Okay, platinum as the cathode, you have this gas being produced. It means that hydrogen ions are going to be discharged. Okay, hydrogen ions are going to be discharged, giving you hydrogen gas. And then at the anode, you will have the hydroxyl ions that come from water. Remember, the ions present, if we can go back here, I can come here. The ions present in dilute sodium chloride are, you have the ions from sodium chloride, so you will have the potassium ions plus the chloride ions, right? That's what you have. But you also have the water also giving you the hydrogen ions plus the OH ions, right? The hydroxyl ions or the hydroxide ions. So these, you have all these ions present. Okay, so it means that you're going to have sodium ions competing with hydrogen ions for discharge, and then you have the chloride ions competing with the hydroxide ions for discharge. Okay, and we are saying that when you have platinum, you'll have hydrogen ions being discharged at the cathode, and at the anode, you will have the hydroxide ions being oxidized to form oxygen at the positive anode. Okay, and this is the reaction that we'll have there. So this is the combination of the overall reactions. This half reaction, combine it with this is definitely what you get. Okay? So there are two gases that are being produced here in the electrolysis of dilute sodium chloride solution. You will have hydrogen and you also have oxygen. The ratio of production of these gases is very important because you can use that ratio to be able to determine the volume of the other. Okay, if you know the volume of one of the gases, then you can know the volume of the other. We have hydrogen being produced thrice compared to that of oxygen. So that means that the ratio is basically 2 to 1. 2 to 1. So 2 to 1, 2 to 1. So that means hydrogen to oxygen. You have this here and that there. Okay, that is that ratio there. So if we produce, this is basically to say if we have 10 liters of hydrogen, that means that hydrogen is twice as much as oxygen. That means that oxygen is actually 5. Okay, that's what it means there. Now, one of the silent things that is happening with this electrolysis is that you are having the concentration of the sodium ions and the chloride ions increasing because actually it is the water that is being used up in this electrolysis. Okay, so that means that as water is being used up, the concentration of these ions is actually increasing. Okay, that is one thing that happens. And also, as the electrolysis continues, now you will have now the chloride, I mean the sodium ions and the chloride ions actually now actively taking part in the discharge. Okay, you actually have sodium coming in to be discharged. Okay, so let's move to the other electrolyte, which is water. Water, which is in its purest form, you will not actually have serious or any really, you have negligible electrolysis happening. Okay, negligible, because you don't have the free ions to really carry this electric current, right? So the electrolysis of water can be enhanced if we add sulfuric acid there. When we add sulfuric acids, it provides more ions for now the electrolysis to happen. So this is what basically happens, and that's why we are having dilute sulfuric acid. The dilute sulfuric acid is the one that provides these ions to be able to carry this electric current. Okay, so always you have oxidation at the cathode, and then you have reduction at the anode. Okay, so oxidation at the cathode, you have the water giving you that is oxygen. Okay, you have oxygen, hydrogen ions. Basically, you have electrons being lost. Okay, you have electrons being lost. That is oxidation at the anode. And then at the cathode, you have reduction. And in this case, you have addition of electrons to get hydrogen gas and the hydroxyl ions, or the hydroxide ions being produced. And if you combine this reaction and this reaction, if you combine the half reactions, you get this as the overall reaction. This is basically to tell you that you will have bubbles of gas that are going to be produced, bubbles of gases that are going to be produced at each of the electrodes. Okay? At the cathode, you will have hydrogen. At the anode, you will have oxygen being produced when you have electrolysis of water. Okay? But the underlying principle is that pure water lacks these free ions. Okay? So it's basically a poor conductor of electricity. So the current can be minimal. Then if you have the impurities in there, then the flow of the current can be noticeable. And therefore, addition of dilute sulfuric acid can actually increase the number of hydrogen ions and sulfate ions, and these ions increase the conductivity of the solution, allowing you to have more electric current flowing and having a rapid electrolytic process happening in there. So let's move to sodium hydroxide solution, the electrolysis of sodium hydroxide solution. The first rule always, when we are talking about electrolysis of any substance, is first know the ions present. Okay, the ions present, that means that you need to know the electrolyte there. And then after knowing the electrolyte there, you need to know whether that electrolyte has water in there or doesn't have water in there. And in this case, when you see this solution, just know that there is water in there. Okay, so you have sodium hydroxide sodium hydroxide, that is N, like that. This is actually giving you, this is in aqueous. So this gives you the sodium ions plus the OH ions, like hydroxide ions. So that's what you have, right? But you also have water. You also have water because it is a solution. So you have this water also giving you hydrogen ions plus the OH ions. Okay? So that is therefore why we have 3 types of ions in each solution. That's why we have the 3 ions in each solution. So still the rules apply. The positive ones move to the negative electrode, which is the cathode. The negative ions move to the positive electrode, which is the anode. And then we will have preferential discharge happening following the rules that we talked about. Okay? The lower the ion in the electrochemical series, the more likely to be the one to be discharged. So the positive ions, we have sodium ions and the hydrogen ions completing. The hydrogen ions are lower in the electrochemical series, so they get discharged. So we have this reaction here showing that discharge, and then the chloride ion, the hydroxyl ions are the only negatively charged ions here. So they are the ones that also get discharged. Okay, so that means that you will have oxygen and hydrogen being produced. Remember that the hydrogen will be produced at the cathode, hydrogen at the cathode, okay, and then oxygen at the anode. So they will ask you what gas is produced at the anode, or gas is produced at the cathode. You say colorless gas that rekindles a glowing splint. When you say colorless gas that rekindles a glowing splint, then you're basically talking about oxygen. Okay, and then if you talk about a gas that has that hot sound, that runs with a hot sound, basically talking about hydrogen. So those are the observations that you basically making. Copper 2 sulfate solution. There is water in there, so I will not go into details. So we have these 4 types of ions present, and then still you go to which ones get discharged in relation to the other. Still the rule of the electrochemical series applies. So at the but also before we go into the rules, we also need to note that it depends on the electrode that we are using. Remember, for when we talked about mercury being the cathode and platinum being the cathode, where we're having different products. So the same concept or principle applies even now here in this situation. So what situation are we talking about? In the electrolysis of copper 2 sulfate solution, when you use carbon electrodes, you're going to have oxygen being produced and then a metal being deposited. Okay, copper, metal being deposited there. But if you use copper electrodes at the cathode, then instead it will actually, the copper anode will dissolve. Okay, the copper anode will dissolve. So that's something that you really need to take note of in this electrolysis. Okay. So when you're having a copper metal being deposited, it means that the copper ions are losing that charge to have a copper solid there. And then if you are having the erosion, it means that the copper solid is becoming ions. It's becoming ions and then going into the solution. So that's what we have just explained. So you will have one part, the copper anode dissolving. Copper anode, if you are having the anode as the copper, it will dissolve. But in this case here, we are having platinum or carbon. If that's the case, then you're not having it dissolving. Okay, and that therefore means that you're having these the ions from the solution are the ones that are responsible for the blue color of the solution. Now, since those ions are being deposited, the blue color actually starts to fade away. Okay, so the blue color, the solution loses that blue color because the ion, the copper 2 ions responsible for this color are being discharged. Okay, that is copper 2 sulfate. We look at dilute sulfuric acid. Still the same story. If you have a dilute solution, you have water there, and then the ions from it, and then you also have the ions that come from the electrolyte itself. So sulfuric acid, you have hydrogen ions and the sulfate ions. And then from the water you have the hydrogen ions and the OH ions, or the hydroxide ions, or we call them hydroxyl ions. Okay, what will happen since you only have the positively charged ions as the hydrogen ions? They really want to be discharged, so you will have hydrogen gas, and then the sulfate and the hydroxyl ions competing there. You will have the hydroxyl ions actually getting discharged, and the overall equation is that there. So the last electrolyte that you're going to talk about is potassium iodide, which is molten. You can use the one, if they say it's concentrated or molten, basically it's the same thing. We are not expecting water in there, and therefore you have the potassium ions and the iodide ions. And these actually will be discharged because they are the only ions that we have in here. So the overall equation is that you have potassium, the molten form, and iodine gas being emitted there. Okay, so that marks the end of this session where we have looked at the different electrolytes and the products that are given out when they are actually electrolytes. When we pass electricity through them, what shall we be able to see? So we've been looking at which one gets oxidized, which one gets reduced. One is this one getting reduced and not there. And what products do we have? And then we have also looked at the concepts to do with what electrodes are we using and how they actually influence the nature of the products that we shall have as a result of the process. Thank you very much.